In this lecture, let me give you a quick overview about the course, okay, and its contents. This course has more than 20 sections, okay, and we're also committed to add more and more lectures in future as we come up with new videos, okay. So the section 1 is just an introduction section which consists of a couple of lectures which will quickly introduce the Beaglebone Black hardware, okay. And in the section 2 we will be concentrating about the initial setup related to the Beaglebone Black hardware, and we will also explore the Beaglebone Black web interfacing. Okay, that means there is a small demo from the beaglebone.org which demonstrates using Beaglebone Black through the web. Okay, so and after that, in the section 3 I will give you a quick overview about the AM225X functional blocks. Okay, so knowing the functional blocks are really important in order to understand the operation of the SoC. So this has 2 lengthy lectures which will introduce the AM225X functional block. Okay, then we have a section 4 which explains Beaglebone Linux booting process. Okay, this is actually a long section consisting of lectures more than 10, and here we will step by step will understand how exactly the Linux boots right from the ROM bootloader until we launch the init program from the Linux kernel. Okay, each and every step is explained with a clear explanation, animations, and practical testing on the Beaglebone Black hardware. We will test RBL, we will test MLO, U-boot, okay, and then we'll test the Linux kernel step by step. Okay, and in between I will also explain the Linux source code as well as U-boot source code to understand how exactly the handing off of control happens from one bootloader to another bootloader to the kernel to the file system. And in the section 5 I will be talking about the eMMC update of the Beaglebone Black hardware with the newer Debian OS. So I will teach you how you can update the eMMC memory with the newer release of the Debian OS from the beaglebone.org. So this section is for people who use Windows as their host, and this section is same, but this explains for the people who use Ubuntu as a host, and for the people who use Mac, then don't worry, it is exactly same and easy as you do in the Windows. Okay, so there is no such differences. Okay, then in the section 7 we will also learn about booting the Angstrom Linux on the Beaglebone Black hardware, and then we'll talk about Linux device tree, why that is introduced in the section 8, and in the section 9 it has a couple of lectures where I will guide you how you can write the uenv.txt step by step from scratch and test it on the Beaglebone Black hardware. Okay, so in the section 10 I will talk about installing Ubuntu on VirtualBox. Okay, so the Ubuntu is required whenever we do core compilations, bootloader compilations, build root compilations, etc. Okay, those compilations cannot be done on Mac or Windows host, so you need a Ubuntu. And some students don't want to have a dual boot on their PC. Okay, so in that case you can install a VirtualBox, and on that you can run the Ubuntu 16 operating system, and in this section I will show you how you can do that. Okay, and after that in the section 11 I will talk about booting the Beaglebone Black hardware over the serial port. So we will transfer all the boot images over the serial port and we will boot the board. Okay, so all these things are done practically, and after that in the TFTP section I will talk about how you can boot your board through the TFTP protocol. Okay, and in the section 13 I will talk about the U-boot, its source tree explanation, the cross toolchain installation, and finally I will show you how you can configure and generate the SPL, MLO, and U-boot images for your board. Okay, and in the section 14 I will explain about the Linux source tree, okay, the ARM architecture, code organization, the board configuration files, the SoC specific driver organization, and finally we will configure and generate the Linux image from the Linux source code that we download from the kernel.org. Okay, and in the section 15 I will talk about BusyBox, and I will help you to generate the minimalistic root file system from using BusyBox, and then we will test it on the hardware. Okay, and I will also talk about the init scripts, RCS, run levels, etc. And also I will show you how you can auto load lots of drivers when you have created your own root file system, and how you can enable lots of functionalities like SSH, the internet or USB. So those things, how you can enable, I will show you in this section. Okay, when you have your own root file system. Okay, and in section 16 I will talk about the build root and how you can configure and generate binaries using build root, and how you can finally test it on the hardware. Okay, great. So in the section 17 I will take you to the Eclipse environment to develop applications for the Beaglebone Black hardware. So Eclipse can be installed in Mac, Windows, Ubuntu. Okay, so it is independent of any operating system. So I will show you how you can write application, cross compile it, and finally how you can transfer the generated binary from host to the Beaglebone Black hardware just using drag and drop method that we call as Remote System Explorer plugin in the Eclipse IDE. So all this I will show you how you can do this. Okay, and in the section 18 these are very interesting topics where I will talk about the pins of the AM335X SoC, how you can map the pins GPIOs to kernel friendly numbers, and I will explain about the GPIO subsystem. I will talk about how you can control the user LEDs from the sysfs entry of the Linux kernel, and I will also talk how you can write your own C application in order to control LEDs. Okay, and in the section 19 I will talk about the external LED interfacing. Okay, and in the section 20 I will talk about interfacing 7-segment LED, either common cathode or common anode, to the Beaglebone Black hardware, and how you can write C application to drive that LED. So all these are Eclipse projects. Okay, and then I will talk about, in the section 21 I will talk about interfacing a 4-digit 7-segment LED to the Beaglebone Black hardware. Okay, and there are other couple of projects related to MPU 6050, accelerometer and gyroscope sensors. So I will show you how you can interface that through the I2C interface to the Beaglebone Black hardware, and we will write some applications to measure the tilt angle of the Beaglebone Black hardware. Okay, and I also have couple of LCD projects, okay, which you can do with the Beaglebone Black hardware along with the WFROM projects. Okay, so this doesn't end here. Okay, I will add more videos related to the wireless networking, the simple driver writing, and the videos related to Bluetooth, touchscreen, etc. So all these are planned in future. Great, so that's a brief overview about the course. I hope you will get maximum benefit out of this course, and let me end this video and I will see you in the next lecture.